The contribution of physics that we intend to share is all about nuclear power. According to the Nuclear Energy Institute, nuclear power is energy located in the nucleus, also known as core of an atom. Nuclear reactions involving changes in an atom's nucleus causing change in the atom itself is a vital process in the emission of energy. The process of nuclear fission, a nuclear reaction, splits apart specifically uranium atoms in order to form smaller atoms, causing the release of nuclear energy. This serves as a reactor directed to a cooling agent, usually water producing steam, which is used to propel a turbine connected to a generator that then generates electricity.
Nuclear power concept began in the 1930s through Enrico Fermi, a physicist, who displayed the ability of neutrons in splitting atoms. Fermi then led a team in 1942 who achieved the first ever nuclear chain reaction in a stadium at the University of Chicago. After a series of milestones in the 1950s, a thought occurred to connect it to the power grid, hence creating the Obninsk, which was the first grid-connected nuclear power plant in the world. The first nuclear reactor that was able to catalyze electricity industrially at a small scale. Then, a year after, the Borax 3 reactor, the prototype for the invention boiling water reactors, made its appearance as the first to generate electricity for an entire community, the town of Arco, Idaho. In 1957, the 60 MW shipping port reactor in Pennsylvania became the first commercial nuclear station to become operational in the United States.
Going forward into our present times, nuclear energy supplies roughly 20% of America's electricity and not producing any greenhouse gases, thus considered by far as the largest source of clean energy in America. Talking about the global scale, around 10% of the world's electricity is generated by about 440 nuclear power reactors. The importance of discovering and utilizing a new generating capacity around the world is significant due to the need of replacing old fossil units, especially the coal-fired mechanisms, that emits huge amounts of carbon dioxide, and also to be able to provide for the high demand of electricity in various countries. Nuclear energy is recorded as the world's second largest source of low-carbon power, about 29% of the total last 2017. The World Nuclear Association mentioned that the world provision of 1/4 of the world's electric capabilities through nuclear energy would significantly reduce the amounts of carbon dioxide emissions and will result in positive effects regarding air quality.
Nuclear power has uses beyond power generation. The technology can be further utilized in medical applications in the hope of combating various diseases. The use of nuclear in medicine is widespread and comes in the form of radiation and radioisotopes, specifically for diagnosis or identification and therapy or treatment of different medical conditions which now are normally used and can be called as routines. In most cases, results and data gathered from these procedures will enable the physician to rapidly diagnose the patient's illness. Radiotherapy is used to treat some medical conditions, notably cancer. It uses radiation to weaken or destroy targeted cells. Across the globe, over 40 million nuclear medicine strategies are enforced every year with an evident demand for radioisotopes that steadily increases at roughly 5% annually, and about 10,000 hospitals use radioisotopes in medicine, wherein 90% fall in the categories of diagnosis.
Humanity has enabled nuclear energy to arrive at its crucial stage of development. Its economic impact of the current generation of plants in the United States has been solely grounded on improved management techniques and careful practices, slowly gearing towards the interest in purchasing new plants. Novel reactor designs can dramatically improve safety, sustainability, and economic effects of nuclear energy systems in the long run. opening doors for possible widespread deployment.